So hello everybody. Today we are going to make a show about how to install Watson AIOps Event Manager, and we want to do that in less than 1 hour. Today I have with me my good friend and colleague Zane Bray. Over to you.
Thanks, Fred. Yeah, so today we're going to installing the Event Manager, which is made up of the legacy Netcore Operations Insight offering, but includes some other embedded items such as the topology capability, Runbook automation, and other new functions. It's the latest in our cloud native offerings. And what we're going to walk through today is how you can get up and running with Event Manager in around an hour by leveraging IBM's cloud-based Kubernetes service.
Will you show how much hardware we are going to need?
Yes, that's right. So we'll start off by looking at the amount of hardware that's required. We'll show how to create a Kubernetes cluster, and we will show how to prepare the cluster, doing a few configuration steps, and then finally install the Event Manager operator and the Event Manager instance and stand it up. And then finally we'll log in and have a look around the UI.
And where are we going to install to?
We're going to install Event Manager on the IBM Cloud hosted Kubernetes service.
Would it be the same if you would install it in a local OpenShift cluster?
In terms of hardware, it is the same. Let me just show you, first of all, the documentation. We'll take a look at what we will actually be installing today. These are the components that we're installing today. It covers the UI, the backend netcall services, the topology capability, the event analytics capability, the automation, and Runbook automation. In terms of the sizing requirements, you can see here that if you're installing all on OpenShift, it has a comprehensive listing of the hardware required to deploy the Event Manager. So in terms of total hardware requirements, it's got Netcall Operations Insight, including the RedHat Openshift control plane and compute nodes.
So when I compare that with a local install on-premise or bare metal, this is definitely a bit more than that, isn't it?
Yeah, so if you look at the hardware requirements for deploying this in your own data center, it actually requires nodes to run the control plane, or so-called master nodes. These nodes control the cluster and control the scheduling of the workloads. In our particular case, we only need to install the worker nodes, the compute nodes, because the hosted OpenShift environment provides the control plane master nodes automatically. So today we will be looking at this particular part of the table here. We will be deploying a trial system. So we'll need 3 worker nodes, 3 compute nodes, each with 8 CPUs, virtual CPUs, 24 gigs of memory, and around 120 gigabytes of disk for each one. So 3 nodes will set up a 3-node cluster. So as a first step, we're going to click on this blue button and create an OpenShift cluster. So the first thing I'm going to do is choose the OpenShift version. The default is 4.5, but if you like, you can choose the latest one, 4.6. The next thing to do is to actually select your OCP entitlement. If you need to purchase an additional license, you can do so here. Or if you already have entitlement based on your ownership of Cloud Paks, you can select that from there as well. The next step is to select which infrastructure that you want to run your cluster on. Classic is the default, which is basically just normal virtual machines running on a native subnet and VLAN networking. The next step is to choose your location. You can choose Asia Pacific, Europe, North America, or South America. In my case, I will choose North America. And then you can choose if you want your worker nodes spread out across multiple locations, so multi-zone. In my case, I'm just going to select a single zone, and then I will choose one of the data centers to run it on, so Dallas 10. The next step, we're going to choose the number of compute nodes, worker nodes we want to have, and the hardware spec of each machine. So if we refer back to the sizing, you can see for a trial version of, we're going to need 3 worker nodes with a hardware specification of 8 virtual CPUs, 24 gigs of RAM, and 120 gigabytes of disk. Of course, it's better to round up a little bit and get something with a little bit more hardware. So let's look for a variety of virtual machine that's 8, 24, and 120, or something close to that. So let's take a look here. We've got something here with 8 32 gigs of RAM, which is a little bit more than 24, but that's okay. And if we scroll across, we can see it has 25 gigabytes plus 100 gigabytes is 125. So this one here seems to fit our requirements quite nicely. We have the option to have virtual dedicated or virtual shared hardware. You can also run it on bare metal if you really want, but that obviously ramps up the cost quite a lot. This one here, virtual dedicated machine with 8, 32, and 125 gigs of disk will fit the bill quite nicely. So we select that one. The worker nodes is automatically set to 3, so that's good. That's what we need. And my worker pool name is default. I'll just leave that. I don't need to encrypt my local disk. It's just a demo environment, nothing particularly sensitive on there. And encryption process does incur some overhead, so I'll leave that switched off. In terms of the endpoints, the service endpoints, you have the option to have be able to access the cluster private only, or public from the public facing point of view, so from an internet, or you can have both. In my case, I'll leave the default that I'm just going to have a public endpoint to access my cluster. That's fine for me. And then finally, it's going to suggest a cluster name. I'm going to just leave the default name, but you could rename that if you wanted to. And then finally, you can add a tag so that you can easily find your cluster or group your clusters if you have multiple ones. I don't need to do that. On the right-hand side, it gives you a summary of what you are requesting. In this case, it's 8 by 32, 8 vCPUs, 32 gigs of RAM, my worker nodes, and 3 of those. The estimated cost will be shown here. And then I just simply click create. At this point, the cloud platform starts to create and provision the cluster that I have requested and takes me to my cluster information page. So as you can see in the top here, it's already started building my cluster. At the moment, it's preparing the master nodes and the worker nodes and bringing the cluster up, configuring all the networking and all that sort of thing. I don't have to worry about any sort of installation or configuration of the OpenShift cluster. It's all done for me, and I can sit back and make coffee while it's doing so. Just taking a look at the menu here on the left-hand side, this first page we're looking at gives us a few pieces of important information about how to access our cluster. The first thing is to set up the command line interface tools. As part of the deployment and installation of Netcool on the OpenShift cluster, we will need to perform some configuration steps for the configuring of the entitlement key, any other configuration steps that we have, and we will cover those shortly. If we want to access the OpenShift web console, we can do that simply by clicking on this blue button here. If we click on the Overview tab, we can actually see the current status of the cluster. We'll be able to see at a glance the status of our worker nodes, if there's any problems, the fully qualified domain name, which we will use later when we're setting up our deployment. At the moment, you can see it's still provisioning, so there's no real useful information here yet. The worker nodes menu item tells us about our worker nodes that we've got. We can see all the information about them, the IP addresses, and it's provisioning at the moment. It's setting up the master nodes first, and you can see the provisioning. So you can see the clusters being provisioned, and you can see all the information about the worker nodes here. If I click on worker pools, I can see how my worker nodes are being allocated to the various worker pools. This is quite useful if I've got different workloads that I want to deploy onto my OpenShift cluster. In this example today, we'll be looking at deploying the event manager, which is part of the AIOps solution, the Watson AIOps solution. If I was to deploy the AI manager, for example, we might have a separate worker pool with a set of worker nodes for that deployment, and that deployment may have sort of different hardware requirements for its worker nodes. So we can actually split up our workloads across our worker pools in this way. For today's example, we just got one worker pool called default with our 3 worker nodes in it. And as you can see, it's active. While we're waiting for the cluster to be provisioned, we'll go take a break, go and make a coffee, and come back and continue once IBM Cloud has finished preparing our cluster.
Can you put a word on the add-ons? What is there? Is there anything significant for us?
Yeah, so that's a good question. The add-ons section contains a number of optional utilities that you can install if you want to add sort of more functionality to your cluster. For example, you might like to access the Kubernetes terminal from your cluster. This one uses the IBM Cloud and Kubernetes command line interfaces for quick access to your cluster directly from your web browser. So this is where you don't need to have command line routing between your cluster and other networks, for example. And there's various other capabilities and options which you can install if you have the need for these. Right. So
sounds like a coffee break now.
I guess it is.
So back with our coffees.
Yeah, starting worker deployment, preparing to meter worker.
So what has changed?
So these worker nodes are being provisioned at the moment. The master nodes have finished being provisioned and the worker nodes are being provisioned at the moment. As you can see, they're at various stages of deployment. So one worker node is up and ready. And I can say 33% of my worker nodes are normal.
Cool. Do we need to care about the IP addresses which are associated to the worker nodes?
No, we don't need to worry about that. They are there so that you can connect to them if you need to, but there's absolutely no need to connect to them. You can see there's a private IP address which is used within the context of the cluster, and then there's a public IP address which can be connected to from externally. So now you can see the second worker node is coming up, and the third one is still in the deploying state. Right, so now 2 are ready, and 1 is just finalizing its configuration.
Do we need to wait for these steps to finish before we can go to post-installation steps?
We need to wait for the cluster to be ready before we can start configuring the cluster, which is the next steps. So how long has it taken, do you think? It's now ready. All 3 worker nodes are ready and normal.
If I look at my watch, something like 15 minutes.
Yeah, sounds about right. Okay, so now the cluster is ready to go. A couple of things to note. First of all, if you need to access the cluster to configure it, there is a way here to set up your command line interface tools. It says here, step 1, download and install a few command line interface tools and the Kubernetes service plugin. So there's a command to help you to do that. Next, download the Openshift command line interface OC that matches your local operating system in the cluster version. Just for example, if I click on here, I can go down and find OpenShift 4.6, which is my version, my cluster version. Click on Linux, and there is the little installation tarball that contains the utilities to run the OC commands during the configuration step.
I would go for Windows for my laptop.
Right, exactly. So once we've done that, we're ready to access the cluster, and we do that simply by clicking on open the web console. The domain is available. Okay, so it's still provisioning. It's not ready. So you need to wait until cluster is fully provisioned before you can actually access the OpenShift web console.
How do you see that?
Well, the first one is when you try to open it, you'll get a message that says this. Ingress subdomain to be available before you can open it. But let's take a look here. One of the things that comes up when the system is available is the fully qualified domain name of the cluster. See when it says Ingress subdomain, see this, Fred?
Yep.
Once this information is available, Ingress subdomain and Ingress status, this is when it's available or Ingress components are healthy. This means that the Ingress into the cluster is ready. Right, so let's go back here. So when the cluster is ready and accessible, you will see information about the Ingress portal into the cluster will be ready when we see information about its status appearing here. Summary. And until it appears, you won't be able to open the OpenShift web console.
Do you potentially need to reload your page, or is it refreshing itself?
It should be refreshing in real time.
So there is some entertainment, I see.
Oh, okay. So you can see here we now have an Ingress subdomain that has a... So let's try to access the web console. First of all, I need to get past the self-signed certificate. Connecting for the first time. You can see I'm now inside my OpenShift container platform.
Nice. That was quick.
Yeah. Before we install the Netcall Operations Insight operator, we have a few steps to prepare the cluster. If I go back to the documentation, you can see there's a link here for preparing your cluster. If I click on this, there's a list of 7 steps that I need to follow just to make sure that my cluster is prepped to be able to deploy Netcall. One of them, for example, is to put my entitlement key, my software entitlement key, and enter that into my cluster, which will enable me to install software. Let's work through the steps. But before we do, we need to open a command line interface to the cluster. We installed the command line interface tools earlier. So let's bring up a command line interface. All of the command line interface tools start with the command OC. If I type OC version, you can see I have the command line interface tool installed. So the next thing to do is connect to the cluster. So how do I do that? Well, I simply click on the question mark and say command line tools. From here, it actually gives me the command to use to connect to my cluster. So I click on copy login command. It brings up a new window, which will give me the exact command to enter in order to connect to my command line interface. So here you can see login with this token. I just copy and paste this and paste it into my command line window. And this will actually connect me securely to the cluster. You can see here that I have access to 62 projects within my cluster. A project is basically a set of items that make up a workload. So there's a whole bunch that are in the cluster by default that run the cluster. So the first thing I can do is I can start to type some commands like OC get pods, and I can see all the various pods that are running in my environment. Ooh.
If you type it correctly.
No resources found. Namespace default. Maybe there's none. Just don't worry about that. Right. Okay, so now we're logged into our cluster. I can close this window and I can go back to my window here. Let's look at the various steps for preparing the cluster. So provision the machines, we've done that. Download and install RedHat Openshift, well, we've done that. The next step is to create a namespace. So a namespace is like a work area within the cluster where we want to deploy our application or collection of applications. So in this case, I'm going to create a namespace called Netcall, or maybe we call it NOI. So that was easy. I've created my namespace. Next step is an optional one. If I really want to restrict the Netcall Operations Insight pods to run only on a certain worker node with a specific tag, I can do these steps. In this particular case, I'm not going to bother with that because I have 3 worker nodes and I simply want to deploy Netcall Operations Insight for a demo scenario. So I'm going to skip step 4, which is optional. The next step is to create a Docker registry secret to enable my OpenShift cluster to pull software from the IBM entitled registry. So to do that, we're going to run this command here, which creates the Docker registry secret. In order to get my entitlement key, I need to click on this link here and log in with my IBM Cloud credentials and get my entitlement key. So I'll do that now. Yeah. Right. So as you can see here, I've logged in and it's showing me my entitlement key. So I'm going to take a copy of this.
Or use the button copy key.
Yeah. And I'm going to put it into a little text editor just to make it simple. I'm going to go back to the documentation and I'm going to copy this command. So the command says OC create secret Docker registry, and you have to give the secret a name. In this case, the default is NOI registry secret. The Docker username is CP. The Docker password is the key that I've just copied. The Docker server is this, cp.icr.io. And the namespace is the one I created earlier. So that's NOI. So I'll copy this command using the copy button. And I'll paste it into my little window here. I'm going to call it NOI registry secret. The Docker username is correct already. The Docker password is this entitlement key. So I'll put that in here. The Docker server is correct already, and the namespace is NOI, N-O-I. So now I've got my command. I'll copy that, and I'll paste it into my terminal window. And what this will do is it will create this Docker registry key secret, which I will then use later when I deploy Netcore Operations Insight, and it will enable my cluster to authenticate with the registry server and pull the software down and install it. So that's step 5.
So where's that file with that key?
Oh, the secret is stored within the cluster. Sorry, the OpenShift cluster. So if I was to...
So you don't need to take a note out of that?
No, it's just the name of it that you have to remember. In this case, it's called NOI-registry-secret. We have to remember. So this is stored in here. If you look for it in the cluster configuration, you can find it under workloads. You can see secrets there. And if you look for it, you will find it in here. Registry. There it is there. You see? That's created. Yeah.
It works.
So step number 5, that's complete now. Step number 6 is optional. This is if I need to create permissions for my special user to be able to deploy workloads on the cluster. If I want to create a specific service account to do this, I follow these steps. In my case, I'm not going to create a specific service account. I'm just going to use the default one, so I don't need to do step 6. Step 7, which is the final step, is more necessary when you are creating a deployment on an OpenShift cluster that is deployed in your own data center. And it's basically just to check that the Ingress controller is able to be accessed from outside the cluster. And what you do is you simply run this command and look at the output. So we'll do that now. And one of the things you're looking for here is endpoint publishing strategy.type. So if I look here, you can see endpoint publishing strategy.type is set to load balancer service. So this is what you get by default by using IBM's Cloud. So it's all nicely load balanced, and ingress into the cluster is automatically set up for you. It says here, if this value was set to host network, that means you need to actually create a network policy in order to allow traffic into the cluster. And you do that by running this command. Because mine is automatically set up, I do not have to do this step. So at this point, the cluster is now ready to deploy the Netcore Operations Insight operator, install it, and then deploy Netcore Operations Insight.
Cool.
So we've finished preparing the cluster now. We finished the final steps here. The next step is to actually, in the cluster, we are going to install the Event Manager operator, and then we will actually deploy an instance of the Event Manager and then log into the UI.
So this is now transferring the Netcool or Watson AIOps Event Manager software into the new cluster and then provision it.
Exactly. So in an earlier step, we added our entitlement to the software registry. This next step is actually installing the operator, as you say, and then deploying an instance of that. Okay, so coming back to the documentation, we just jumped down a couple of steps to installing, and we're going to install the procedure as it says here, using the Operator Lifecycle Manager, OLM, is to first of all create a catalog source for Netcore Operations Insight, and then using the operator that gets deployed as a part of that, we will actually deploy an instance. So the first step is to go into administration, cluster settings, global configuration, operator hub, and add a new source. So let's do that now. So we go into administration, cluster settings, global configuration, and we go down to the operator hub. And what we're going to do is we're going to add a new source, a new operator. So these are all the default out of the box ones. They're all to do with RedHat and Openshift. So what we're going to do is we're going to create a new catalog source, which will contain the operator for the IBM software. Right, so carrying on here, we're creating a new catalog source. The name of the source that we're going to create is IBM Watson AIOps catalog. And then looking at the documentation, the display name is, we can use the same value.
So it's really important to make it this value you just said, isn't it?
Yes. IBM-Watson-AIOps-catalog.
Because otherwise it will not work. So therefore, pay attention to it when you create it.
Right. For the image, this is from the documentation. You simply put this source here, and what it's saying, this is the repository where the IBM operator catalog is located, and we simply want to tell it to take the latest version. So that's what we're going to put in here. And we want to make this catalog source available across the entire cluster, not just on a certain namespace. We just make it globally available. So create that. And what you'll see here is it has added it to the bottom here, the bottom row, as a catalog source. And you can see at the moment the number of operators is currently a hyphen. That's because it's currently connecting to this catalog source and querying it and pulling down all the latest information about all the available operators. So we just give this a few minutes to refresh.
Cool, another coffee break.
Exactly. So this takes about 2 or 3 minutes to finish downloading all the operators. Yes. Yeah. Oh, there we go. So now you can see we've got 38 operators. It's finished downloading those.
Oh, that was quick.
It was pretty quick, yeah, just a minute or two. And then the next thing is to actually go into the operators, and we will find the operator that we want to use, and we'll install that operator, and then finally we'll create an instance of the event manager. So we simply go to the operator hub now, and you'll see we have a lot more operators available to us than we did before. So the one we're going to look for is Netcool Operations Insight, which is the other name for the event manager. This is the one that we want, and we are going to install it. Because we put in the repository source the latest, it's always going to attempt to get the latest. So this particular operator, we'll just leave it as the default settings to take the latest one. We're going to just specify a specific namespace to install into. In this case, the one we created earlier called NOI, and we will install that now. Once the operator has finished installing, we will then be able to use that installed operator to deploy an instance of Event Manager or Netcool Operations Insight onto our cluster. And as the message says, this operator is being installed. It may take a few minutes.
So this is just linking stuff, isn't it? So it's not downloading the actual package.
When we set up the source, we're actually saying this is my full list of operators. When we install the operator, we're actually pulling it down off the source and installing it onto our local cluster. So it's pulling the software down at this point, yes.
Do you know how many gigabytes of stuff it is?
I don't actually know.
Because that's a huge difference when you install it locally or in the IBM Cloud as we do.
Yeah, it is pulling down the images that are required to deploy an instance of Netcore Operations Insight. So this is basically pulling the software down. So that's finished now. So now if I go to my installed operators, you can see I had the one that came with the cluster, the package server, but now I have this new one, Netcore Operations Insight, ready and available to deploy into the NOI namespace. So from here, the last step is simply to deploy an instance of this particular software bundle. So in this case, I'm going to choose cloud deployment because I'm going to install it onto this OpenShift container platform. So I'll do that now.
So everything in just one installation.
Right. And as you can see here, currently I have none installed. I haven't created any yet, but I'm going to do that now. So create an instance, and going through the various pieces of information here, I just have to choose all the various options that I want. So in this particular case, I give it a name. I'm going to just leave the default example NOI. I can choose to give this particular deployment a label. These labels can be handy for grouping collections of deployments. I'm not going to bother with that this time. The fully qualified domain name for my cluster, this is a key point. You can get this from your cluster. Back in the IBM Cloud, it's got my Ingress subdomain here. So this is my fully qualified domain name for my cluster. So copy it from here and paste it into this box here. This is used by the software when you deploy it to enable the UI for Event Manager to be exposed and accessible outside of the cluster. So my entitlement secret, this is like my license key. This is the one that I created earlier in the registry, and it's my NOI registry secret. Do you remember we created that on the command line and we downloaded my entitlement key? Yeah,
we did that.
Under license, I just have to accept the license agreement. That's fine. I'm going to choose the latest version 163. This will be a trial deployment, and then we basically go through each of these and select the options that we want.
The trial deployment switch is quite important because it will choose resource consumption, isn't it?
Right, yeah. And it's also, I think, associated with your entitlement as well. So for the integrations, Humio is an option. I'm not going to do that today. LDAP is if I want to integrate it with my corporate LDAP server. For a trial scenario, I will probably just keep the standalone one, so the built-in embedded LDAP server that comes with the deployment. So I'm not going to connect to a corporate one. I'm just going to use the embedded one today.
So I guess these additional integrations would be something for another video.
Right. So all the way through these configurations, I have to actually tell it which storage class I want to use for each thing. Now, in a trial scenario, we can actually just use one of the default ones, and IBM C Block Gold is suitable for this purpose for a trial environment. If you're doing a production deployment, this might be your vSphere storage, or it might be your NFS storage or something else. But in the case of the trial, we're simply going to use the built-in OpenShift class called Block Gold. The default sizings, I wouldn't recommend that you modify these unless you're an advanced user. The default settings are perfectly suitable for a trial deployment. So next one is persistence. Do we want to enable persistence? Event Manager has a great deal of stateful data. If a worker node goes down and has to be reinstantiated and comes back up again, we don't want to revert back to a vanilla system. We actually want to not lose all of our data. So what this does is it just says, if I do have any stateful data, I want you to actually write it to a persistent location so that if my worker pods get restarted or something goes down and has to come back up, the data will be recoverable.
So it's a really good idea to enable that.
Yes. For each one of these, I have the option to actually specify where I want to store the data. And just like for the other one, we're going to choose IBM C Block Gold for each of these. So I've selected all my storage classes for all the various components, and you can see the default allocations for all of these are all predefined. You can just leave them all set to their various settings. The next one is topology. By default, topology is enabled. This is really important because topology is an exceptionally valuable capability in the Event Manager. So we definitely want that switched on. The network discovery capability is a special type of observer called the net disco observer.
I guess that's down to the type of test and development system we are trying to do here. If we want to demo something like network discovery, this would be a good choice, but for most of the scenarios, I don't think we need that.
That's exactly right. Yep. So you can switch that on if you think you're going to need the net disco observer, but otherwise I wouldn't bother. For the rest, though, I recommend you may as well switch them all on, because unless you know which ones you want, well, we may as well have them all. Just to note that you can, after you've deployed this, you can come back into the configuration and switch them on. If you didn't switch them on and realize actually it'd be quite handy to have these, you can actually come back here, switch it on, and it will actually deploy those observers. So it's not like this is your only chance to do it. You can come back and do it later. And then for the topology piece, again, just as before, we're going to tell it where we want to store any persistent data. And the Elasticsearch and the file observers both have persistent storage options here. So again, we'll choose IBM C, block, gold for those two. Again, we've got the sizes, so we'll just leave those as the defaults. Backup and restore, we're not going to bother about enabling backup at the moment. And under advanced configuration, there are a few items here, but again, if this is just a trial version, we're not really going to bother about messing with these too much. So just a review, we've got our name, we've got our fully qualified domain name, we've got our entitlement secret, we've accepted the license, selected the latest version, trial deployment, we're using standalone LDAP, we've defined our storage class, we've enabled persistence, enabled the storage classes for each one, we have enabled topology, we have enabled all the observers, and we have specified the storage classes for the Elasticsearch topology and for the file observer. The last thing to do is hit create. So click the button. And as you can see here, the first thing it does is it's reconciling. So what that means is it's going through the configuration settings and assessing what it's going to need in order to start to build the deployment. In my case, I've selected most of the options, so it's going to be selecting the various parts that it needs to actually roll out this particular deployment. So this process can take about 15 minutes. So if it's lunchtime, this would be the time to go off and make another coffee, and maybe even a sandwich too. Yep, this one, eventually it will say phase OK under the status in the middle.
Great, Zane. So we have now finished installing all these components, which are now appearing in the red circles. Let me see, red circles, here we are. All these components which do make the event manager, we have now installed into a single OpenShift cluster. This cluster is actually hosted on the IBM Cloud, but it could also be hosted in a local data center or somewhere else.
Okay, so Fred, you can see now that the deployment has completed. It now says it's okay. So the last step now, we can click into this and have a look, and it's giving us a whole load of sort of information about how to do this and how to do that. But the key one is how to log into the console. It actually gives you a command here, kube control get secret example noi ICP admin secret blah blah blah. And if you ran that from your command line, it would actually output password. The other way to do it is simply to go look it up in the secrets on the console. So example noi ICP admin secret. If we go into the workloads and we go into secrets, we can actually just scroll down to example noi ICP admin secret and click on reveal values. So this gives us the ICP admin password to log into the UI. Yeah.
This is a randomly generated password.
Right.
Can we change it?
Yes, you can. I can change it here. So what I'll do is I'll just save that for now. We'll try and log into the UI now that the deployment has completed. So where is the UI?
It's another hidden treasure in this response text.
Yeah. Well, yeah, so it's basically here, IBM console. We'll now try and log into the UI. So we take the basically https:// and then the name of netcool dot and then the cluster name. So let's do that now.
It's a pretty long name.
Yeah, so basically this is derived from my cluster's name. So as you can see, it's brought me to the login UI.
Mm-hmm.
The login, the default one is ICP admin. Oops. And the password is the one that we just got. Copy that, copy, and paste into there. So it's logging in now for the first time. And as you can see, we now have a fully functioning netcool operations insight, aka event manager deployment. Click on events. I can see my events here in the event viewer, loading it for the very first time. There's always self-monitoring events. They're always there. Yeah. We will also be able to, from here, configure integrations into other systems. So if we have some cloud event sources, we can start configuring to receive those events.
Cloud native event integrations.
Right. And we can also start to look at topology and things like that. Just a word of note, if you don't see any of the topology things, that's because your user, the default user, doesn't necessarily have the permissions. So what you can do is open the netcool web GUI, and we just quickly tweak the user to have all the permissions. So I do that by opening the ICP admin user, and I'll just give him all of the roles.
Ooh,
right.
Master of disaster.
Yeah.
For a demo, it's okay.
So now ICP admin has all the roles, so I can close this now. And what I'll do is I'll just log out and re-log in again. ICP admin, and the password is the one that I copied from my little page. And now I've got topology as well, as you can see. Along with that comes the ability to configure the topology, including defining new observer jobs. And do you remember I selected all the possible observers under the sun?
Mm-hmm.
You can see they're all there listed waiting for me to configure.
Yeah, lots of fun.
Just like before, I've got the runbooks. We can now integrate into our automation targets, such as Ansible Tower or BigFix. Yeah, so as you can see now, we have a fully functioning netcool operations insight deployment with all of the runbooks, the integrations, the topology, and all the various capabilities.
That was pretty fast.
Yeah, so
I'm amazed.
We created a cluster. Just to recap, we created a new OpenShift cluster. We installed the netcool operations insight operator, and we deployed netcool operations insight. And within less than an hour, we have a fully functioning system that we can start to build integrations and do demos from.
And if we want to twist and tweak the installation, we should go into the hybrid installation operator, and there we can do all the amendments that we need to go into a more configurizable environment. But this is for a demo perfect, I would say, because it installs everything in a running environment, everything pre-connected together, and all these components are there, ready to play.
Yeah, and if you do have any existing probes or an existing netcool environment, you can simply point those probes at the event manager, because hidden inside here is an object server. And similarly, you can set up an object server gateway to pipe events from your existing environment into this new system. If we just take a look at the architecture, you can see that the various components that we've just deployed is everything in this picture. Included in the yellow boxes here, as you can see, is an object server. The gateways are like the object server gateway that connects the object servers together.
Would be cool to have the single probe in this package as well. For training and educational purposes, this would be really cool.
Yeah, so another session might be, okay, I've got the system now. Now, how do I connect probes to it? How do I feed my events from my legacy system into it? How do I discover what port my object server is exposed on?
Thank you, Zane. I think I owe you a really big thank you. These are really good ideas. So we do have already a pool of ideas of what we can do in further videos. So if you, the welcome audience, do have also some ideas, please send me or Zane an email about what you want to see, what we should do in here. We have the possibilities to create quite quickly these kind of videos, so just leave me a message. You have it on a screen here, and thank you for today. See you soon.